Hello everyone. On this video I'm going to discuss the concept of taking moments about a certain point, which is the concept that we're going to be using a lot when we are solving the structures, more especially when we're calculating reactions or calculating member forces in a truss. So please listen very carefully. Questions, you know where to find me. Just before we go to that concept, remember on the video below we had an inclined point load. In this case is P1. On this slide I am showing you how to work out the vertical component of that force P1 and the horizontal component of that very same force. Remember, we cannot solve that P1 if we are not working out the components of the force. So to solve for that issue or for that problem, we need to work out the vertical and the horizontal component of that P1. P1 sine theta being the vertical component of P1, meaning is Py, and then P1 cos theta being the horizontal component, which is Px. Remember, we've discussed that on the previous video. Moving on, moments. Moment is just a turning effect. Remember, you're applying a load. If you are not applying a load through the center of whatever action of center, obviously you will develop moments in that beam or in that frame. So your moment is either the load is go or the beam or the structure is going to rotate about that point either in the clockwise direction or in an anti-clockwise direction. Please remember that moment either going anti-clockwise or clockwise about a certain point. Again, when working out the moment, remember is the force. In this case is P1 times the perpendicular distance. Perpendicular distance being that distance as x1 from the line of action of that force P1 to where you are taking moments or you are calculating moment. In this case we are taking moments about A, so the force P1 has a perpendicular distance of x1 to point A. In this case, if you look now, how P1 is rotating, point A is rotating clockwise. Hence, in that equation there, I'm saying sum of moments about A, sum of moments about A is equal to P1 times x1 going in the clockwise direction. That the rotation, very important, guys, because if you mess up the rotation, your signs are going to be messed up, then everything is going to be a problem. So it's very important. Again, remember, there is no such a thing that clockwise is positive or anti-clockwise is positive. No, as long as you assign the same sign to the same rotation. If they all go in the clockwise direction, you can assign positive. If one is going clockwise, the other one going anti-clockwise, just assign different signs to take into account that they are going in the opposite direction. There is no such a thing, I'm repeating again, that clockwise is positive, anti-clockwise is negative. Right now we've got three forces, P1, P2 and P3. If you look at point A, the force on the right hand side is P3. P3 is rotating that beam in the clockwise direction about point A. P2 is also rotating Can you see how P2 is coming? It's also rotating that that point A in the clockwise, or that beam about point A in the clockwise direction. Meaning those two forces you must assign the same sign, whether you choose to assign negative sign or you choose to assign positive sign. But the signs for P1, the moment caused by P1, and the moment caused by P2. Please forgive me for the first equation next to the diagram. The right equation is the equation below the diagram. I've forgotten to delete that equation next to the diagram. Please forgive me about that. The right equation is the one below the diagram. Okay, now let's look at the equation below the diagram. I'm saying P1 times x1 is rotating it anti-clockwise. Forget about the signs at the moment. P2 times x2 is rotating clockwise. P3 times x3 is also rotating clockwise. Watch the signs now. I'm assigning the same signs for P2 and P3 because they're going the same direction. Whereas P1 is, I'm assigning a different sign, which is negative in this case because it's going opposite direction to P2 and P3. P2 and P3 being the P2 times x, the moments there are going clockwise, the other moments are going anti-clockwise moments. It's up to you. You can assign P1 the positive, but remember now, if you assign the anti-clockwise rotation as positive, so the other two, which is going in the clockwise, you must assign the negative rotation. Please always remember that, guys. That is very, very critical when you are taking moments about okay, now let's look at uniformly distributed moment. I know most of the time my students are struggling with this one, but I hope you will find it very easy. We have a load that is applied over a distance. So W, look at the units, kilonewtons per meter. So the first thing, you must convert that load into point load. Hence I'm saying W times X. So by doing that, I am converting the uniformly distributed load into point load, and the line of action of that point load is acting at the center. So the center, that line, the hidden line, or the dotted line, is not the dotted line, sorry, it's the hidden line that I'm showing there in that diagram, is showing that W times X is acting there, halfway there. So what is the distance now? So we're done with the force now. What is the distance from the line of action of that uniformly distributed load to where you are calculating moments? The x over 2 is the distance from the line of action to where you are calculating moments about that uniformly distributed load. The moments is right at the far end, so I should be having A there, right at the far end of the beam. That's why I'm saying sum of moments about A. It's going anti-clockwise. It's the only force there. There's no point assigning negative or positive, as long as I know the direction of the moment is going in the anti-clockwise direction. Then let's look at the uniformly distributed load now, but it's not applied over the entire beam like the one above. So again, I'm going to convert that uniformly distributed load into a point load acting acting where I'm showing the hidden line. So how do you convert that? Take the UDL, multiply by the distance over which the UDL is applied over. Then that UDL is W, multiply by X, which is the distance is applied over the X distance. Okay, then I'm done with that. Now the next thing, now what is the distance from my line of action to where I am taking moments? So the distance is that x over 2 plus x1. So I've got this other distance here called x1. So the distance is x over 2 plus x1 to where I am taking moments. It's rotating in an anti-clockwise direction, and again I am not showing that as a negative, because remember, negative and positive, they just we just use them to differentiate between different rotations, not because negative, anti-clockwise is negative or clockwise is positive. There is no such a thing. Please let's not do that. I hope you are clear. It's very important that you understand the second example. Being now, you've got point A at mid span. You've got UDL going over the span. Now, the UDL on the right hand side of point A is rotating the point A in the clockwise direction, while the UDL on the left hand side of point A is rotating it in the anti-clockwise direction. So the distance from point A to the far right is m. The distance from point A to the far left is n. So watch this now. So W times m, I'm just converting the UDL into 0.0, and then I know the line of action is shown there. So times m over 2. What is m over 2? The distance from my line of action to where I am taking moments, and it's rotating in which direction? Clockwise. Then I use negative in this case. I said clockwise is negative because remember I said it's not important which one is negative. Then I go to the next one. W times n. Then I've converted that. I know that is acting at the center of my load, and then I multiply by n over 2. N over 2, the distance from where from the center of my UDL. Which UDL now? The one on the left hand side, to where I am taking moments, to A, and that one is going anti-clockwise. I hope you understand the concept. Feel free to ask me questions on WhatsApp or via email or even on Teams for that matter. If further discussions on the topic. Thank you very much, guys. Enjoy your day and keep safe. Bye.